Have you ever wondered how SF6 circuit breakers work? Well, brace yourselves because we're about to dive into the fascinating world of SF6, or sulfur hexafluoride, a colorless, odorless, non-flammable and highly stable gas with excellent electrical insulating properties. This makes it a star player in the high-voltage circuit breaker league. SF6 circuit breakers operate by extinguishing the arc formed during the interruption of an electrical current. When a fault is detected, the circuit breaker releases high-pressure SF6 gas into the arcing chamber. This gas, being a superior insulator, displaces the air and quenches the arc, ensuring a rapid and reliable interruption of the current. However, it's worth noting that SF6 is a potent greenhouse gas, and its use has environmental implications. That's why efforts are underway to find alternatives. Now that we have a basic understanding of how SF6 circuit breakers operate, let's delve into their advantages and why they are widely used. SF6 circuit breakers bring several benefits to the table, making them a popular choice in high-voltage applications. Let's dive into what makes them stand out. First and foremost, SF6, or sulfur hexafluoride, boasts exceptional electrical insulating properties. This characteristic allows for the creation of compact and efficient circuit breakers, making them fit well in settings where space is at a premium. Secondly, SF6 has a high dielectric strength. This means that it can effectively interrupt high-voltage currents without requiring a bulky physical structure. This trait significantly contributes to the compactness of SF6 circuit breakers. Another advantage lies in SF6's stability and inertness. This colorless, odorless gas is non-flammable, ensuring the safety and reliability of the circuit breaker. It's chemically inert, meaning it doesn't react with other substances under normal conditions, further enhancing its stability. When it comes to the interruption of electrical currents, SF6 truly shines. The gas effectively extinguishes the electrical arc formed during a fault, leading to a swift and reliable interruption of the current. This feature is critical in preventing electrical fires and other potential hazards. SF6 circuit breakers are also known for their low maintenance requirements. Unlike some other types of circuit breakers, they don't necessitate frequent upkeep, making them cost-effective in the long run. Finally, the stability of SF6 lends itself to a long service life. SF6 doesn't degrade easily, which means that SF6 circuit breakers can serve for extended periods, ensuring an excellent return on investment. Given these benefits, it's easy to see why SF6 circuit breakers are favored in many applications. However, they do come with their share of drawbacks. The most notable of these is the environmental impact associated with SF6, a potent greenhouse gas with a high global warming potential. Consequently, there is a continuous search for alternative technologies that can deliver the benefits of SF6 while mitigating its environmental impact. Despite their many advantages, SF6 circuit breakers are not without their drawbacks. The primary concern is their environmental impact. You see, SF6 is a potent greenhouse gas. When released into the atmosphere, it has a global warming potential significantly higher than that of carbon dioxide. This means that even small quantities can contribute substantially to climate change. As we become more aware of our need to protect the environment, this feature of SF6 becomes a significant disadvantage. In response to these environmental concerns, governments and organizations have implemented stringent regulations and guidelines to control the use of SF6. These regulations require careful monitoring and management of SF6 emissions, which can add complexity to the operation and maintenance of SF6 circuit breakers. It's like having a high-performance sports car that requires special fuel and constant fine-tuning. It's fantastic when it's running smoothly, but it needs a lot of attention to keep it that way. In addition to the regulatory challenges, there's also the issue of end-of-life management. Once an SF6 circuit breaker reaches the end of its service life, it can't just be tossed in a dumpster. The SF6 gas inside needs to be carefully removed and properly handled to minimize its release into the environment. This disposal process can be costly and time-consuming, another disadvantage to consider. And speaking of cost, while SF6 circuit breakers have a reputation for being low maintenance, they are often more expensive upfront than their alternatives. This high initial cost, combined with the extra expenses associated with SF6 management and disposal, means that the total cost of ownership can be higher than expected. These disadvantages highlight the need for alternative technologies that can maintain the benefits of SF6 while minimizing its environmental impact. The search for these alternatives is ongoing, and while we may not have found the perfect solution yet, the progress made so far is promising. So, while SF6 circuit breakers continue to play a vital role in our electrical systems today, the future may hold new and exciting possibilities. Given the environmental concerns associated with SF6, the search is on for more eco-friendly alternatives. The quest for greener alternatives to SF6 circuit breakers has led to the exploration of several interesting technologies. Let's delve into some of them. First up, we have vacuum circuit breakers. These devices interrupt the electrical current by creating an electrical arc in a vacuum, an environment where the arc can't sustain itself. The arc is extinguished and the current is interrupted. Vacuum circuit breakers are compact, require little maintenance and produce no harmful emissions, making them an attractive alternative to SF6 circuit breakers. Next, we have air-insulated switchgear. This technology uses compressed air to extinguish the electrical arc, interrupting the current. While air-insulated switchgear is typically larger than SF6 circuit breakers, they don't contribute to greenhouse gas emissions and are therefore more environmentally friendly. Carbon dioxide, CO2, and fluoronitride, C4F7N, are also being researched as potential insulating gases. Although CO2 has a much lower global warming potential than SF6, it's less efficient as an insulating medium. On the other hand, fluoronitride is a promising alternative that combines the insulating properties of SF6 with a significantly lower global warming potential. Another promising technology is the solid-state circuit breaker. These devices use solid-state semiconductors to interrupt the current, eliminating the need for gases altogether. Solid-state circuit breakers are highly efficient, compact, and produce no emissions. However, they are still in the developmental stage and not yet widely available. Let's not forget about the hybrid approach, which combines the benefits of different technologies. For example, a vacuum interrupter can be used for the braking operation and a low global warming potential gas for insulation. This approach can offer a good balance between environmental friendliness and operational efficiency. While these alternatives show promise, SF6 circuit breakers continue to be widely used due to their reliability and efficiency. The journey towards finding the perfect alternative is ongoing, and it's an exciting space to watch. The future of circuit breakers is not only about maintaining electrical efficiency, but also about embracing environmental responsibility. SF6 circuit breakers play a critical role in our electrical systems, but they are not without their challenges. In this discussion, we've taken a deep dive into the world of SF6 circuit breakers, their advantages, disadvantages, and the ongoing quest for alternatives. SF6, or sulfur hexafluoride, is a remarkable gas with exceptional electrical insulating properties. Its high dielectric strength, stability, and inertness, coupled with its ability to efficiently interrupt high-voltage currents, make it an ideal choice for circuit breakers. We've learned that SF6 circuit breakers come with several notable advantages. Their excellent insulating properties allow for compact, efficient designs. They have a high dielectric strength, enabling the effective interruption of high-voltage currents. Furthermore, their stability, inertness, and efficient arc interruption capabilities ensure their safety, reliability, and long service life. And let's not forget their compact, lightweight design and low-maintenance nature, which add to their cost-effectiveness. However, we've also acknowledged that SF6 circuit breakers are not without their drawbacks, primarily due to environmental concerns. SF6 is a potent greenhouse gas with a high global warming potential. Its release into the atmosphere contributes to climate change. As a result, there are stringent regulations and guidelines in place to monitor and control its use, adding operational and maintenance complexities for users. The end-of-life management of SF6 circuit breakers also poses challenges, as recycling and proper handling of decommissioned SF6 equipment are necessary to minimize environmental impact. It's clear that while SF6 circuit breakers have served us well, the ongoing search for environmentally friendly alternatives is crucial. The challenge lies in finding technologies that maintain the benefits of SF6 while addressing its environmental impact. As we continue to strive for more sustainable technologies, it will be interesting to see how the future of circuit breakers evolves.